Hello. Okay. Hi guys. Sorry for the delay. We have set up a YouTube live stream as well. So for the people who weren't able to join, and if there are any errors here in the call, you guys can watch it from there. Am I audible? If you guys can let me know, I'll.
Yeah, Rishabh, you're audible.
Yeah.
You're audible.
Okay.
Which is
Okay,
the
cool.
channel name? Channel name.
Sorry.
YouTube channel name.
Oh, we shared the link in the WhatsApp group.
Thank you,
Could
sir.
you repeat what you said? I was not able to hear you before.
Oh, all I said was that we set up a YouTube live stream, and
Okay.
we'll start now. And if
So-
there are
so-
any issues, you guys can watch it from there itself.
So will you also be on Google Meet as well, or do you all have to shift to YouTube Live?
No, you guys can stay. We'll. This is what is being streamed. So
Oh, okay, cool. All right.
yeah. Okay. So we'll start off. I'll present my screen just. Let me know if you guys are able to see.
It's visible. It's we're able to see.
Okay, cool. So, yeah, just give me a second. All right. This is going to be a pretty basic workshop, and we'll be covering the basics of Arduino. And I'll be taking it at a slow pace itself, although I am assuming there are quite a few of you here who already know the basics to a good extent. And if there have been anyone who has been following the Learning Path courses so far, or anyone who was there in the Rotaract Club's workshop yesterday, they'll see that I'll be repeating some of the things I mentioned there. So you guys can feel free to just look through at a higher level for now, and just make sure that everything that is covered in this workshop are things that you know, and it'll be required for the task that you guys will be given at the end. So this is what we'll be covering for the class. Just a second. Okay, so we'll be looking at a blinking LED, and like blinking an LED, which is like the equivalent to a Hello World program here, and reading from the serial monitor, which we'll be working on like 3 projects basically, and making an automatic brightness lamp using PWM. And then I'll give you guys a little bit of info of how we can use a motor driver, how we can make it to make an Arduino car. So basically you send commands and then the car will act accordingly, moving front, back, left or right. And we can also make it a wireless car by using the HC05 Bluetooth module. That is also something we'll be covering here. And we'll also be looking into Pi serial. So you can basically send commands to the Arduino's serial monitor using Python codes, which is something you guys will need when you're getting into image processing for coding your Arduino projects and dynamically using it with image processing codes. So yeah, this is about it. I'll just give a basic introduction. So Arduino basically, robotics as a whole can be thought of as a continuous loop of sensing, thinking, and acting. And for sensing, it takes information from its sensors, and then it processes it and decides what to do, which is kind of incorporated in the thinking part. And acting is what it does while controlling its actuators, which is like motors and robotic arms, which are again controlled by motors, and LEDs and so on. So here we'll be mostly looking into how we can use sensors and actuators, and how we can take information from sensors and make actuators like LEDs and motors work, and based on sensor inputs, sensors like the LDR or an ultrasonic sensor per se. So that is it. And one thing that I would probably like to give a little bit of importance towards would be that Arduino is a very good starting point, because whenever you guys are improving the thinking aspect of robotics, let's say if you're working on an image processing code, or if you guys are developing any ROS software, for example, the thinking part of robotics incorporates a lot of errors that comes up, and or many of them which you are trying to deal with when you're trying to estimate what will be the best way forward. You will actually have to deal with the errors that come up because of the sensor measurements, and also to be able to make a code that's actually possible to be able to put on a robot directly, you will need to be able to communicate with the sensors and actuators altogether. So understanding how low-level drivers work, it'll give you guys a very good boost towards trying to work on other robotics projects which involve image processing and other areas like simultaneous localization mapping, for example. So yeah, all of this is the same. So yeah, an Arduino is basically like a microcontroller, and it's actually a pretty straightforward thing that we can use, and it's a very good starting point, like I already mentioned. Basically, it has pins, and it'll be communicating using voltage differences between sensors and actuators, and we will be looking into how we can do this in detail moving on and moving forward. And also there are different types of Arduino boards like Arduino Nano, Micro, and there's the Arduino Lily Pad as well. Right now, as far as this workshop is concerned, we'll be looking into the Arduino Uno. So yeah, communication protocols. So there are three, like broadly categorizing, there are three communication protocols that you guys can look into. We won't be going into a lot of depth here, but it's always good to probably read about this by yourselves. So there's Uart and SPI and I2C. And SPI and I2C, basically, they have a clock, and they also have a master and a slave way of communicating. And they have differences in the numbers of pins that you require when you're trying to communicate. And you can see, look into it more and see how different sensors, probably some of them have a different communication protocol that they require when you use them. So yeah, this will be a pinout diagram for an Arduino Uno. And as you can see, there are different pins with one pin having multiple things that it can do. For example, broadly categorizing, there are digital and analog pins. And digital pins would be pins that you can use for input and output, and analog would be mostly used for taking an input. I'll get into more detail of this as we move ahead. So digital and analog, the biggest difference here, which is something we will have to look into with a little more detail, would be that a digital pin would only be able to give and take signals as high or low, so as 1 or 0, as the definition goes. And an analog can take a wide range of values. So it basically, like between the highest and the lowest voltage, rather than just being on or off, it can have a value in between as well. So you can regulate how much you want to give or take in a sensor or an actuator. And you can see that there's a reset button, there's a power jack, there's a USB port, and yeah, so forth. And some of these pins, as you can see, as these 4 pins here, 13, 12, 11, 10, are also pins that can be used for SPI communication. And there is I2C communication here in the first 2 pins, which is the SCL and SDA, serial clock and serial data pin. And there's a serial port here for Uart, which is the RX and TX ports, which is something we'll be looking into for the HC05 Bluetooth module. So yeah, we'll get into more of this as and when we go ahead with the project. So yeah, this is basically a good way to structure how the Arduino is. There are sensors which will take input from the environment, and they generally take input as an analog signal. So for example, if you have an LDR, let's say, what it does is it changes its resistance based on the amount of light that's there in the surroundings. So this is a sensor which will tell the Arduino, basically give an idea of how much light there is in the surroundings. Now it gives a wide range of values. It doesn't have to be only 1 or 0, that there is light or there is no light. It can have a different intensity. So there are generally, as far as I have seen, the values range between 0 to 450. So there can be a wide range of values. And that's why, since this is an analog value, it's not only 0 or 1, it can be converted to a digital signal, which the processor will use for the thinking part, let's say. And then the processor gives information to an actuator to act according to it. So the actuator would be given either a digital signal or an analog signal as per the requirement. But the Arduinos don't have a D2A converter, which is a digital to analog converter. So that is when we'll be requiring something called pulse width modulation. PWM, we call it. And that is basically like using digital signals to be able to allow it to act like an analog signal, so the actuators can perform and we can regulate the actuators as per our requirement the way we would if we had an analog signal given to it directly. So this also we'll be looking into more detail as and when we go to the projects. I don't want to go completely into the theory right away without you guys implementing it. Otherwise, it probably won't be as helpful. Yeah, these are breadboards. This is something which is actually very handy when you're making projects, because it allows multiple pins to get connected to the same voltage. So here, if you see horizontal holes, as you can see in the picture, these are all linked together. So all of them, all the pins that you connect here would be a part of one wire, let's say. And vertical strips are also connected together. This again is something you guys can just get used to as and when you're working on projects. You don't have to remember this right away. And yeah, talking about Arduino IDE, this is something right now, today we'll be working on with Tinkercad, which is a simulation software. But Arduino IDE is something you'll need to install if you're planning to work with the hardware. And you can code here in the Arduino IDE and also see things in the console, and there's a serial monitor. And this by itself is something you guys can learn to use after you install it and if you guys work on with the hardware. So for now, you just need to know that there is something called Arduino IDE that you'll need to install and work with. And yeah, just a second. Okay, I'll share the link for the Arduino IDE, just installation. You guys can also just do it. Sure. Yeah, so based on your operating system, you guys can. Yeah. So moving on. As far as the coding part is concerned, we'll be using C++ for the Arduino IDE. And the C++ variant here is not, it's actually pretty simple to use because especially as far as Arduino codes are concerned, we only use basic if-else, while loops and for loops. So basic conditional statements, if you guys know, and it's very similar to C, so there's nothing different if you guys have studied C. If not also, it is something you guys can actually just understand the syntax as and when we go ahead and build the codes. So it is not something you guys should probably worry about. That is actually a very simple implementation, as and when you guys go ahead, you'll be able to see it. And yeah, this is something we'll be requiring today. So you guys will have to sign up on Tinkercad and use simulations, start simulations so that you guys can work on the project side by side. I'll just give the link to this as well. Does anyone have any questions with anything I explained so far? If everything's clear, we'll move ahead.
What was this link again? Tinkercad?
This is the simulation software. So today we'll be using this to simulate Arduino programs. So you guys can actually make connections and also write the code and see it working in the software. So you can actually go to that website.
Yeah, so we are getting two options. Start tinkering, join your class. So do we do join your class?
Oh, no. Just sign up normally. Like probably start tinkering is
okay.
good enough. Yeah. Okay, if you guys have signed in, okay, yeah, then you guys can go ahead and if this is how your dashboard should look. So there is an option called 3D designs, and below that there's an option called circuits. So you'll have to click on that and then click on create new circuit. If you guys have gotten it so far, just type a yes in the chat box. Once most people have gotten it, we'll proceed. Okay, cool. So once you guys have done this, we'll start off with the first thing that we work on, which would be making a blinking LED. This is, like I said, an equivalent Hello World program, so it's something you can start off with to get used to all the basic workflow of the Arduino code and how you have to make the connections. So once you guys have opened one simulation, then you can scroll on the right side and find an Arduino Uno R3. And if you're not able to search, if you're not able to find it here, then you can just search for it and just drag it to the screen here. After that's done, you guys can drag an LED into the screen as well, and you'll need a resistor as well. If you an LED always requires a resistor here, because otherwise there's too much current through the LED, so the LED can pop. And in the simulation, nothing of the sort would happen, but there would be an exclamation mark. And we generally people start off with using pin number 13. We will be using pin number 12. I'll tell you how to make the connections. But I generally think that it's better to use a different pin, so that because pin number 13 has inbuilt resistance, and if all the codes generally have there's already an inbuilt code, so you don't really get to change the code and understand how it's working if you don't use a different pin. It's a good practice. So,
do the other pins have any like inbuilt resistance or any other significance, or are they just normal pins you can use for any purpose?
For a blinking LED, as far as we are concerned, we can use any of these digital pins. There are some pins which have specific significance. For example, the pins which have the tilde symbol next to them, all of those digital pins can be used to give a PWM signal, which I'll talk about later, which would basically be giving an analog signal using a digital signal, basically. But for now, all of these pins numbered from 1 to 13 are fine. And 13 has an inbuilt resistance. I am not sure if any of the others do. As far as I know, they don't.
Okay.
So, yeah, that's pretty much it.
And also, I mean, instead of connecting a resistor, is it not possible to control the current flow so that it doesn't overload the LED?
Actually, I think the current flow in these digital pins are, I mean, the voltages that an Arduino Uno provides is, I think, fixed. So you will have to use a resistor, because if the voltage is fixed, the only way you can control the current is using the resistor.
Right.
So yeah, this is again, there could be a way, but whatever implementation I've worked on and projects I've worked on so far, I have never seen changing the amount of voltage that these digital pins get.
Got it. Thank you.
Yeah. Okay. In case you guys are, I don't know if this is happening, but if you guys are getting kicked out of the meeting by itself because of some error, or if you're not able to see it properly here and leaving and trying to join again, it could be easier if you guys just watch the YouTube stream, if that helps. Okay, anyways, moving on. So after you connect the resistor to the LED, you connect the other end of the resistor to the ground pin. You guys should be able to see that there's a ground pin here, and the other end of the LED to pin number 12. this is your basic LED connection. And the code, if you guys click on code here, you will see code written in blocks. You will have to change that to text because that is how you will have to implement everything later on. So it's better you guys get used to this now itself. So after clicking on code, you click on this drop down menu and choose text. And I'll explain the overall look of the code. So in general, how an Arduino code works is there'll be two loops, a void setup and a void loop, basically two functions. And the void setup would run only once, and it would be generally used for things like initializing certain pins as either output or input. So the Arduino knows which pin it has to take input from or give an output signal to. And if you're communicating with the serial monitor, you'll have to write serial.begin. This is also something we'll look into for the next program that we work on. And that is also something we'll be putting in void setup. So basically, void setup is an initializing stage. And generally, this is a misconception. If I have heard of this, like the reset button here on the Arduino board doesn't really factory reset your Arduino with the code that's inside, like the Arduino losing out its memory. It's more like running the void setup again. So in general, what happens is the void setup runs only once and then the void loop keeps running. But if you press the reset button, void setup just runs again and the code starts from scratch. And then the void loop is, it's basically like equivalent to a while true statement. So it would keep running. And that is required because in most of the implementations, at least, you'd want, like this is a generic case, by default, you would want code to be running forever. So if you're using, making an automatic door per se, you wouldn't want the door to open only once when somebody tries to come inside, and then stop after that. You would want that code to keep running. So void loop runs forever. And there are some other functions you guys will be able to see here. There's pin mode, which we'll be using to declare any pins as input or output. So if you can see here, LED built-in is written. You guys can change that to pin number 12 because we have connected the LED to pin number 12. And in the void setup loop, as far as for this particular circuit, this is all you'll have to put. And in void loop, we'll have a digital write, which is basically like writing the pin as either high or low, so giving the sending current there. So here also you change pin number 12. It has two arguments, the pin number and then high or low. So here pin number 12, high. This will allow the LED to blink. And there's a delay of 1000 milliseconds. That's basically 1 second. So we wait for 1 second after sending current through the pin, and then we give it a low signal. So then the LED switches off, and then we wait for 1 second again. So this code will basically allow a blinking LED to work. So if you start simulation here, you should see that the LED blinks with a 1 second delay. Now, if you guys wanted to blink a little brighter, you can change the resistance to 0.1. That should be all right. Yeah. So that's a blinking LED. If you guys were able to implement this, again, just type a yes in the chat box so I can know that we can proceed. If you have any doubts or anything of the sort, we can work it out. Okay, cool. Yeah. So then we can move on to the second project that we were going to look into. 1 second, let me just look at the slides for that. Yeah, so for the second project, we'll be using the serial monitor. This is the second project. Before I go into the technical details, what this project is basically about, it is a Morse code visualizer. So if you guys know about this, Morse code is basically a way of communicating by only using two symbols. dots and dashes. And so what we do over here is the LED blinks for like 50 milliseconds if we give a dot as an input, and 1 or 2 seconds if we give a dash as an input. So this way, it's whatever Morse code you give, the LED will be able to act accordingly. So it's like a visualizer. So if I give this for example, I gave 3 dots and a dash. So the LED blinked for 50 milliseconds 3 times, and then for a longer time for the last character that I gave to it. So what I just opened here is called the serial monitor. And in the simulation, you guys can see that if you click on code and then see at the bottom, you have an option to access the serial monitor. What the serial monitor basically does is it can take an input and also give output. So if you ever want to print anything in the serial monitor, you can, like, if you just put a serial.println or print function here in the void loop, or then it'll print something in the serial monitor. It's basically just an output input box here, and if you are using the Arduino Ide, then the serial monitor will be in the top right in the general case. So there'll be like a magnifying glass kind of a symbol. That's basically the serial monitor. And yeah, for using this, looking into the code, what we basically do is it's the same thing, pin mode 12 output. And here we write serial.begin 9600. This serial.begin 9600, what this line of the code does is basically telling the serial monitor that we are going to be communicating with it. And 9600 is the baud rate. It's basically at what rate the data will be given to it. And the rate is important because the serial monitor and the code have the same alignment of what rate it is. Only then there won't be any data that is missed out. So 9600 is a very general case, and I haven't ever used any other baud rate, although I have seen some projects and some implementations in which changing the baud rate is required for some other code. But for most cases, 9600 is what we move ahead with. So yeah, serial.begin.
So if we change the baud rate, then the rate of data speed transfer will be more or less, or it will be fluctuated.
Yeah, so basically when you change the baud rate in the code, you will also have to change the baud rate in the serial monitor.
Yes.
Yeah, so I don't know if that where the changing option is here in the simulation, but when you open Arduino Ide, you will be able to see that there is an option to change the baud rate of the serial monitor as well.
Yes, sir.
Yeah, yeah. So so when you change this baud rate and keep it both aligned, then I don't think there should be any issue with the data communication. But there are some requirements based on the sensor as to what the baud rate should be. But yeah, like I said, 9600 is all that I have needed to use with many of the basic projects that you guys can also make. Even if when you're communicating with the serial monitor for making a wired and a Bluetooth car, 9600 is what we generally use. But
yes, sir.
You can look into other things. Don't call me sir. Yeah. So
Okay. Yeah.
Right. Yeah. So you guys, you can just look into some other projects if you want to see how baud rate changes the requirements. That should be good enough, I guess.
Thank you.
Yeah. Okay. So serial.begin 9600 would be the initializing line in the void setup loop. And now in void loop, what we do is we write ch equal to serial read. So basically, I'm reading something from the serial monitor and I'm storing it in a variable called ch. It's of the type car. So if you don't have experience with C or C++, basically you have to write the type before the variable, because a variable can have different. It can store values of different types, and because we are putting a character here in the serial monitor, you write car. So serial.read is a function that allows us to get the value or get the input from the serial monitor. So then we just use an if-else statement. if ch is equal to full stop or dot here, then just like how we had the blinking LED, we write digital write 12 high, but for a delay of 50 seconds, and then low again. And if it is a dash, then digital write 12 high with a delay of 1 second. So yeah, 50 milliseconds and 1 second is, I think, an observable difference. And this is pretty much all that there is in this code. So if you guys want to print something to serial monitor, you guys use serial.print. And if you want to read something, you use serial.read. That's pretty much all you need to know for the communication part of it with the serial monitor. So I've already showed you this, but just in case, I start simulation. If I give a full stop, it blinks only for like 50 milliseconds. And if I give a dash, it blinks for a second. I can give any combination and it'll do that accordingly. It would be nice if you guys are doing this by the side by yourself as well, so that you guys have proper clarity, and if there are any errors that come up, we can try and debug it. And if you guys are done with this, you guys can.
Dishab, is the meeting being recorded for later access?
Yeah, it's being recorded because it's also being streamed on YouTube. Right? I think it's going to be there even after the.
Oh, okay, great. All right. And if possible, can you share the slides after the meeting as well so that we can go through it?
Yeah, I'll do that.
All right, thank you.
Yeah. Okay, yeah. So if you guys were able to implement this, just write a yes in the chat box so I know we can proceed.
I had one doubt. Could you explain what the high and low is again?
Okay. So basically, high is kind of like giving it the maximum output. So you're just saying that you're giving it a high signal. Wait, let me go back to the blinking LED ones. So if, let's say, I remove these two lines here. I don't even think we need a delay, but it's just going to be high the whole time. So what high is basically doing is giving a current. So you're just saying that, yeah, so give a voltage difference at that pin. So you're just telling the Arduino that at that point, you give a maximum voltage difference. When we look into analog outputs, then you will also see that rather than writing only high or low, we can give any value between 0 and 255. So 255 would act like high and 0 would act like low. And high and low is basically just inputs that we give to the pins, as we're just telling what output level they have to give. So if it's low, it's just off, and if it's high, it's just on. That's all.
Okay, thank you.
Yeah. Okay, there are only 3 yeses. We'll probably wait for a little more. If you guys have any doubts, you can ask. Okay, we'll move on. So the third project that we'll be working on uses PWM. So before that, I'll just explain a little bit about the LDR and about PWM. So the LDR is a sensor, a light-dependent resistor. So what it basically does is changes its resistance based on the light in its surroundings. And we'll be reading from this to be able to make actuators behave according to the brightness of the surroundings. So the connections for an LDR to an Arduino is how you, as you can see over here, you connect one pin to an input pin here, to an input voltage pin here in the Arduino, either 5 volts or 3.3 volts. and the other you connect to a resistor, and the resistor is connected to ground. I'll explain about the third thing that's connected to A0 right now, but just the basic connection over here to complete the circuit is connecting one end to 3.3 volt or 5 volt input voltage, and the other end to a resistor, which is in turn connected to ground. Now, from the point where the LDR and the second resistor are connected, you take a wire and connect it to any one of the analog pins, which will actually be declared as input pins in the setup, in void setup. So you basically take input from there. So it just reads what the voltage difference is. Now, this is a very common doubt which comes up when you're looking into an LDR, that the LDR by itself is a resistor. So why we require a second resistor is generally a confusion. So the basic thing is that we want there to be a difference in the voltage, because we'll be reading the differences in voltages. Now, if there was no second resistor, then no matter what the resistance of the LDR would be, how it would change, the difference in the voltages between the 5 volt, let's say we connected to a 5 volt pin, so the difference between the 5 volt and that A0 wire would always be 5 volts. It would only be the current that changes. But if you have a second resistance connected and you in series, and if you take the point from the middle and connect it to the one of the input pins, one of the analog pins, then you're basically also changing the voltage between those two particular points, when the LDR resistance changes. So then you can measure the differences in voltage, and that's basically what you're trying to read. So assuming you've understood how an LDR is connected, I'll move on to PWM. So pulse width modulation, like I mentioned before, is basically because a system we use because Arduinos don't have a digital to analog converter. So we want to give it an analog. We want to give analog outputs to actuators, and to do so, we want to give any value between 0 and 255. So, for example, an LED, if you gave it a low or a high, it's basically switch off or switch on. But you want an LED to be able to have a particular level of brightness. In that case, you want to give it an analog output. But because it does not have a digital to analog converter, you can't do it directly. So pulse width modulation, what it basically does is sending a high and a low signal at a fixed frequency, which is a very high frequency, and just changing the amount of highs and lows that you're giving in that cycle. So what that does is, towards the end, it averages out and acts like an analog signal. So what you do is, for example, if there's a 50% duty cycle, you're basically at a high frequency, you're sending highs and lows such that the number of highs and lows are 50-50. So there's a high and a low and a high and a low. So when that keeps happening, the average actual voltage, as you can see in this diagram in the green line, it averages out to 50%. And if there's a 10% duty cycle, there are 9 more lows than highs. So in that case, the average becomes 10% of what you want. And 90% duty cycle would, and so on. So basically, you just have to, you don't have to mention like all of that, the frequency and all that. You basically write analog right and pin number, comma, and the second argument would be any value between 0 and 255. So that's all pulse width modulation is about. You're just using digital signals to make it act like an analog signal. And the pins which are marked with the tilde symbol in the Arduino board, amongst the digital pins itself, those will be the ones which you can use for PWM communication. Yeah, now we'll try and implement this automatic lamp. What this project was going to be is kind of representing how your phone's automatic brightness works. So based on the brightness of the surroundings, the LED would blink, the LED would glow. So if the brightness is at full extent, then the LED will not glow. And if there is zero brightness, then the LED will glow with its brightest amount. That's at 255. So yeah, before I go into the code of this, does anyone have any doubt with PWM or LDR?
So can you please explain a bit again what actually PWM does?
Okay, I'll go back to this slide 1 second. Yeah, so here, if you noticed, a processor would like there's a sensor, there's a processor, and there's an actuator. So sensor will sense the input in its surroundings and give it to the processor, and the processor would process it, and based on certain conditions, give output to the actuators. Actuators can be motors or LEDs and whatsoever. And you want to regulate the amount by which you're controlling the actuator. So I think the best example is the LED itself. So right now, if you see, when we used a blinking LED, all we said was high or low. So what it did was, it was either switching on the LED at its full extent or switching off the LED. That is a normal digital signal. But what if you want to make the LED glow, but only at half the amount of brightness? You could change the resistance value, but if you want to do that dynamically, you can't always keep switching the resistance that way. So a much easier implementation of that would actually be if you just, rather than trying to switch between resistors or make connections which only certain pins get a certain amount of output, you can directly do that by using PWM. So PWM is basically sending digital signals at different rates to act like analog signals. So if you would have seen from this graph, yeah. So there can only be a signal of a high or a low, but when you are sending many signals at a small amount of time, so basically at a fast rate, so the frequency is high, and you switch between highs and lows according to how much you want the signal to be, it can act like an analog signal. So what PWM is basically doing is, you're allowing the actuator to act at a certain amount of output. So like at a certain amount of power per se. So you could like make the LED glow at 70% or 50% or 42%, let's say, or make a motor run at a speed not of its maximum speed or not completely switched off, but at half the amount of speed that it generally does. And basically all of that. It's just using digital signals to make it act like analog signals. That's all that PWM does.
Yeah. Yes. Thank you. Thank you.
Yeah. Okay. Can you show the connection between the LDR? Yeah, I'll show it once again. Probably if I show it here, it'll... Okay, fine. I'll just show it there. That'll be better. Yeah, so this is the connection from the LDR to the Arduino. One end is connected to 5 volts or 3.3. The other end connected to a resistor, and the other end of the resistor is connected to ground. And the point between the resistor and the LDR is connected to one of the analog pins. When we are going to be working on this project right now, maybe it'll fit into. It'll help you remember. So yeah, I'll just show you the connections first. Just like how I showed it in the slides, the LDR, one end is connected to 3.3 volts here. The other end is connected to a resistor, which is connected to ground. And the point, like the same end, which was connected to the resistor, is connected to A0. You can connect it to any one of these 5 pins. I've connected it to A0. And the LED here, because it's a PWM implementation, you will have to connect it to a pin with the tilde symbol. So I've not connected it to 12 because 12 doesn't have that. So I've connected to pin number 11. I'll just show you the simulation first. So you can see that the LED is at its brightest amount right now. And as and when the brightness of the surroundings increases, the LED completely switches off. If I keep it somewhere in the middle, the LED blinks with it glows with a lower brightness. And the maximum brightness is when the brightness in the surroundings are 0. So if you're trying it with hardware, there obviously wouldn't be a slider here on the LDR, because the LDR is just sensing the brightness in the surroundings. For the simulation purpose, we're using a slider. It simulates, so it acts as the brightness in the surroundings. Now, looking into the code, before you try to connect the LED or try to make the LED glow at a certain brightness based on what the LDR is doing, or any sensor that you use, in fact, the best way to proceed, according to my experience, is when you first try to print the values that the sensor is getting, because that's obviously only the only logical way to proceed. Once you know what the range of values are that the sensor is giving to you, then you will know what to make, what and at what conditions it's giving those values to you. You can make the actuators perform accordingly. So if you notice here, if I open the serial monitor and start simulation, the LDR is printing a value of 4 at its minimum extent. So that means like 4 is an equivalent number to the amount of brightness. And as and when I take the slider towards the other end, you can see it's reached 341. It goes all the way to 448 towards the other end. Back to 4. So that is the LDR's values being printed. And using these values, I use this function, the map function, to control the brightness of the LED. I'll explain what the map function does. Let's just look at the other parts of the code so far. So I declare this variable called brightness of the type float, so it can have any decimal values as well. And in the void setup, pin mode 11 output, that's instead of 12, it's 11 here. Like I told you, the LED is connected to pin number 11. And pin mode A0 input, so A0 input. This is the input pin that the LDR is connected to. This is the pin that will be reading the value from the LDR. And serial dot begin 9600, like we saw in the code before. In the void loop, what I do is I declare a variable of a type integer, int a, analog read A0. So this function analog read, it reads the value from the pin A0. And it has only one argument, which is the pin number. So I have declared A0 here as input, and I use that as the argument of the function analog read. And this value is stored in int a. Now here I use cl.print ln a. This is the part that was printing the output in the CL monitor. So ln basically, like cl.print also is something you can just write, but cl.print ln helps you print with a new line. So with a new line symbol at the end. So it basically goes to the new line, prints everything in the new line after the first time it's printed something. So this basically allows me to print the values of the LDR input to the serial monitor. Now what I do is I write brightness is equal to map of 5 arguments here. I'll explain what it does. So basically what I'm trying to do over here is I'm trying to get the equivalent output. I'm trying to get an indirect relationship between the LDR's output and the LDR's input and the LED's output. So from cl.println, we could see that the LDR is giving an output of between 4 and 448. And like I told you, because we are trying to make a simulation in which if the LDR has like senses the least value it possibly can, then the LED will glow at its brightest. And when the LDR has the highest possible value, the LED will glow at 0. So basically what the map function does is the first argument is the first variable that you want it to consider, which is A over here, which is basically the input of the LDR. The second and the third arguments are basically the lowest and the highest values of that variable. And the fourth and the fifth argument are the corresponding value that you want this variable to take. So here I've used the variable brightness, the value that that you want this variable to take corresponding to these values. I'll explain this in a little more detail, but basically what map function does over here is for a value of 4 that the LDR reads, then for a value of 4, brightness will be equal to 255. For a value of 448, brightness will be equal to 0. And for any value between 4 and 448, there'll be an equivalent brightness of the LED between 255 and 0. So it's basically a way to just get an indirect proportional relationship between the brightness and the input value. And then you write analog write 11, comma brightness. So here it's basically any value between 0 and 255. I've written brightness here because it's a variable that I have already declared as a float type between 0 and 255. So you can put any number here. Analog write is just like digital write. The two arguments that it takes is the first one being pin number, just like digital write. The second one, rather than being high or low, it takes any value between 0 and 255. I'll show you guys what you guys could do instead of using a map function, just so you understand what the map function actually did. One second. So if you see here, I have used the map function again for some other code where I was trying to find, based on the distance of an obstacle at which an obstacle is present. This is for ultrasonic sensor. Then based on that, there would the LED would blink, would glow at a particular brightness. This is again indirectly proportional. So instead of the map function here, what you could also do is use something like this. So it's basically doing the same thing. So if you see, if I copy paste this, one second. Yeah, I'll change this to 448. I'm just going to assume that the LDR was giving values rather than between 4 and 448, it's giving between 0 and 448, just for the sake of simplicity right now. So this will should still work the same way. One second. Oh, right, sorry, my bad. Yeah, so if you see, this still works the same way. So even without using the map function, you guys can get the same implementation. What I have done over here is I have written an indirect relationship between brightness and the variable A. So when the variable A takes a value of 448, then brightness will be equal to 0. When the variable takes a value of 0, then brightness will be 255, because 440 and 448 will get cancelled. And any value between 448 and 0, for example, if it's taking 248, then the brightness of the LED would be 255 into 248 by 448. So basically dividing 255 units into 448 parts, and then taking the 248th part of that. So it's just an indirect relationship. So you can use this instead of using a map function, but a map function generally makes things easier. So I'll switch back to that, and I'll probably copy paste this code in the chat box if that makes things easier.
Excuse me, it's showing an error in the code in int A and in analog write.
Oh wait, sorry, I'm not able to hear you. It's showing an error?
In the line void loop inside int A and analog write.
Yeah, you're supposed to write analog read here because you're reading the value in an LDR.
Yeah, I did that.
Oh wait, it's showing an error for you in the last line, is it?
In the last line also and in the first line also.
Okay, do you mind streaming your screen so we can like see what the error is?
Yeah, okay, just a minute.
Yeah. Okay, you'll have to put a semicolon after serial.println.
Okay, done. It's still showing an error.
Right, just a second. Expected initializer before. Oh, have you used dash like minus symbol rather than equal to? int A, have you used my int A equal to analog read or?
Sir, you must use equal. Yeah.
Oh yeah, sorry. What's the difference? What's the error here? Analog write 11 brightness.
Expected, wait years. Oh, and also someone just texted that your resistor is not connected to the ground. LDR
Oh yeah,
sensor.
yeah.
Yeah.
All right, okay.
To ground.
To ground where we are in A.
No. Ground on the left.
Oh, okay.
You'll see G and D. Yeah.
Yeah.
Try running it now, and there should still be an error. Yeah. There's
It's
still an
still.
error. Can you just read out what is written in the console, because I'm not able to see it clearly.
Analog write 11 comma brightness semicolon.
No. In the console, like what did they say? Expected what?
Oh, expect semicolon before bracket token exit status 1.
Have you missed the semicolon somewhere once?
No, there's semicolon everywhere.
Okay, someone's saying you put a question mark instead of semicolon somewhere?
No, it's semicolon. It's semicolon.
Okay.
Sir, you use actually curly brackets instead of normal brackets in analog, right?
Right, yeah.
It's curly bracket, yes.
Yeah, you have to change the back.
So small. Yeah, it did work. Thank you.
Yeah, cool.
Yes, sir, welcome.
Hi Rishabh, I had a doubt.
Yeah. Hi.
So for the code part, like now we have taken 448 because that is what we got in the when we printed.
Right.
Suppose we are doing it with the actual hardware. How do we know what value to take?
Oh, even if you're doing with the actual hardware, you can print it. Because if you're using the actual hardware, you connect an LDR, you can still code the LDR to, like you can still code cl.println A, and you can store A in analog read. Like the code would be the same actually.
But then we have to make sure that we get the extreme conditions right?
Right, yeah. So when you're coding with the actual hardware, you will have to like find a way to be able to simulate the extreme conditions beforehand if you're trying to work on a project, let's say. So, for example, I think the most extreme condition that the LDR could be under would be if you switch on your phone's torch and just put it on the LDR. That should probably be the maximum value that the LDR would read. But I think the best way, the safest way to implement this would be to actually simulate the same environment that your robot would be in, and for all the possible conditions, just read what the LDR values are beforehand.
Okay, thank you.
Yeah.
Or just Google what are the extreme conditions.
Yeah. But for hardware implementation, the extreme conditions can be various based on what you're using it for. So like if you're using it in a mine, let's say, like extreme conditions, as in it doesn't have to be the LDR's potential. It's more like trying to say what would be the extreme condition in the particular implementation that I'm trying to use the project in. Okay. If you guys were able to understand this and get this to work, again, just type a yes in the chat box so that, one second, someone asked it out. Okay, answering the first one, could you please demonstrate the execution again? Right, so, wait, when you mean execution, you just want me to simulate it again? So what it's doing over here is that for the lowest possible value of the LDR. The LED is blinking, is glowing at its brightest. And as and when I take the slider to make the LDR, exposing the LDR to more surrounding brightness, the LED is dimming even more. And towards the end, the LED switches off. That's the execution. I'm not sure if that answered your question. Okay, cool. Yeah. And one second. Okay. And we can use serial.println A and show high brightness on the photoresistor. And fine. I didn't really get your question, Sushant.
Yeah, she asked in the when we connect it physically, how to find the value of the photoresist, right?
Right.
So we can use that command so that it prints the values as we increase the brightness on the photoresistor. So we can on a torch and show really high brightness to the photoresistor, and we can record the value which gets printed.
Oh, okay. So you're basically just answering that question, is it?
Yeah, I'm asking, is it possible?
Yeah, that's possible.
Okay, thank you.
Yeah. LED to analog in this case. Yeah, LED to analog should also actually work. Although, since we're using PWM, and PWM requires you to obviously connect it to a digital pin, you would give a digital output. But yeah, see, if you notice here, it says analog in. I'm assuming that's for analog input. I have not connected actuators to analog pins so far, but I have seen cases where people can actually control motors using analog, analog pins, because rather than using a motor driver, if it's a very simple motor which requires very less voltage that the Arduino board can directly provide. So I think it should be possible. Yeah, you can try that out. Okay. Assuming you guys are fine with everything so far, I'll go ahead with the next part. So this was all I had planned for the Tinkercad part of it. Now I'll just give you guys the theory for how you can use a motor driver, and because this is how you'll have to make a car. A Bluetooth controlled car will also require you to be able to use this first. So a motor driver is basically something you connect to your Arduino, and then you connect your motors to the motor driver to implement a car. So you have a chassis that you connect both your motors to, and you connect your Arduino to it as well. You connect your Arduino to the motor driver, and you just place all of it on top, and then you can run it by giving commands on the serial monitor. So if you can see the motor driver spin out diagram here, there are outputs 1 and 2 and outputs 3 and 4 on the extreme right and left of the motor driver. Those are basically the things that complete the circuit with the motors. So you'll be using two motors. Let's say if there's a two-wheel drive here. So the two motors would be each of them would be connected to one side of it, and one of this completes the circuit with the motors basically. And
Rishabh?
yeah.
Yeah, sorry for interrupting. A friend asked me to tell you that there are doubts in the YouTube live chat as well, and they are asking a lot of doubts. They wanted their doubts cleared as well.
Oh, okay. I didn't see that.
Yeah.
1 second. Give me a second.
No worries.
Okay. Okay, I'll send all the codes to to the people who are not attending on the Google Meet, I'll basically send the slides and the codes that we used in the WhatsApp groups after the workshop. Why do we prefer C++? Arduino codes are just made on C++. I don't know why they prefer it, but what I think would be the motivation could most probably be because it's a compiled language. So execution is much faster once you've finished making it, because you don't have to interpret it while the execution is going on. And also C++ over C is because then you can use things like classes and objects, which allow you to use it for more complicated uses as well. And no, indentation doesn't matter. No, you can actually declare the brightness variable inside void setup as well, and yeah, it would be preferable to declare it either outside or inside void setup, but inside void loop would not be nice, because if you declare it again and again and void loop runs again and again, it would probably slow down the code. And also, let's just check. Yeah, it's better if you declare it beforehand, because it allows for faster execution, but it shouldn't really matter. Yeah. Not exactly like representing any global or local. It's not about the whether it's a global variable, local variable right now. I mean, as far as the implementation is concerned for this particular project, because that part wouldn't really make much of a difference in the implementation. So if you declare it even inside, that should work. Wait, I'll keep that. I'll keep the live stream as well open as well once. Give me just a second, guys. Okay. Yeah, so coming back to the motor driver. So here you'll be connecting two motors to the motor driver, and the motor driver will be connected to the Arduino. And the two motors will be connected to out 1 and out 2 and out 3 and out 4. So one of them for each of the sides. And I mean, the two motors will be connected to those parts of the motor driver. And the three other pins that you can see over here, which have the screws in that blue shield kind of a thing, those are basically VCC and ground for the motor driver. So motors generally require a higher voltage, so it's generally like 12 volts. So the Arduino wouldn't be able to provide that. So what you do is you have an external battery that you connect with the motor driver, and the ground and the voltage of the battery would go into pin number 1, pin numbers marked 1 and 2 over here in the motor driver. So if you want to use the motor driver with only a 5-volt input, then you can use this third pin over here, and you can actually send that from the Arduino itself directly. But I think if you want a car that functions better, it's always recommended to use the 12 volts input. And ion 1, ion 2, ion 3, and ion 4 are basically what you will be requiring. Those pins will be connected with the Arduino, and that is what will be required to give the commands to the motors, basically. So ion 1 and ion 2, these two pins over here, I don't know if you guys can see my mouse, but you guys should be able to see from the image that ion 1 and ion 2 here would basically give the act as input for one of the motors, the motor towards the left, and ion 3 and ion 4 for the motor towards the right. And how it works is, if ion 1 and ion 2, if both of them are 0 or both of them are 1, then the motor doesn't move. If ion 1 is 1 and ion 2 is 0, then the motor would rotate, I think, clockwise or anti-clockwise in one of the directions. And if ion 1 is 0 and ion 2 is 1, then it would rotate in the opposite direction. The same thing with ion 3 and ion 4. So each of, like, basically it takes 1 0 1 1 0 0 0 1. So there are 4 possible inputs it can take. 2 of them do the same job. They keep the motor off, and 2 of the inputs will either allow the motor to rotate clockwise or anti-clockwise. And based on what you give, different combinations will allow the robot to either move forward, backwards, or one of the motors can be stationary and one of the motors will move either forward or backwards, so allowing it to turn left or right, but not exactly by being at the same spot, or allowing it to turn left or right by staying at the same spot, which is when one of the motors is rotating clockwise and the other is rotating anti-clockwise. So I'll show you guys the code that I made for this. That should probably clear things up a little more.
What does ENA and ENB do?
Yeah, I was going to get into that. ENA and ENB basically allows you to control the speed of the motors. So this is where PWM comes into picture again. So you can basically connect ENA and ENB pins to PWM pins on the Arduino, and you can give values between 0 and 255. And if you don't connect them, it's still fine. The motors will run at 255 only. And if you connect them, you can control the speed of the motors, basically.
Thank you.
Yeah. Okay, so this code, this is the code, and yeah. So in the setup loop here, you can see I've defined a bunch of things here in the beginning. You don't really have to do that. I have just done that for so that it becomes easier to read. So LB, LF, RB, and RF are basically IN1, INA1, INA2, INB1, INB2. And one of them is for the left back, left forward, right back, right forward. Based on which one I give as 1, it would either, that particular wheel would move back or forward, basically. ENA and ENB I haven't used in this code, but I just declared it, not required. And there's a delay of 50 milliseconds that I use in the middle of the code. So in the setup loop, I have used serial.begin 9600, and pin mode, I have declared all of these as output pins in the Arduino, because the Arduino will be giving the signal, and an analog write. Here, I have just declared it in the setup itself because I don't change it, basically, during the code. So I've written ENA and 255, ENB 255. So this is allowing the motors to run at its full capacity. In void loop, I have used this if condition saying if serial.available greater than 0. This condition you don't have to use again, but it allows like it's more sophisticated, because only when there is a serial available basically returns a value greater than 0 if there is some communication that the serial monitor is able to receive. So in case of any errors that might come up, if it is not greater than 0, then the code will just end right there. So you know that there is some issue with the serial monitor not receiving data. But if it is receiving data, then you guys can go ahead into this condition. And here I write car CG is equal to serial.read. So now I'm again taking input from the serial monitor, and I'll be taking one character, a single character, as which will either be F, B, R, or L. And based on the character, I'm basically what I'm doing at a high level is writing which pins have to be like between the INA1, INA2, INB1, INB2, which pins have to be written as high and which pins have to be written as low. I'm writing that down based on, like, I'm using digital write to use to see which ones have to be high and low corresponding to what command I've given and corresponding to the connections I've made. Sometimes you have to use trial and error to try and get the precise one, because what happens is if you're, let's say, you give INA1 as, you've made the INA1, INA2 connections such that if you give INA1 as 1 and INA2 as 0, then it would move clockwise. But then if by any chance to output 1 and output 2, you have switched the motors that you have connected it to. So basically, if here you've just switched the wires of the motors that you have connected to, then it would run at the opposite way that you want it to run. So rather than keeping all of that into account and getting it perfect at the first shot, which would actually be more energy consuming, you guys can just use trial and error and see what is allowing the car to actually move forward because of the directions at which the motors is rotating. So over here you can see LF and RF are high and LB and RB are low when I give CG equal to F. So this is an if statement. All of these are just if statements. So if CG is equal to F, which is basically me typing in the serial monitor. By the way, in Arduino Ide, here is where the serial monitor is. Right now I've not connected an Arduino, so it says not available. But if you've connected an Arduino and if you try to run a code, you can open the serial monitor. And if you type an F in serial monitor, what this code would allow me to do is write LF and RF as high and LB and RB as low, allowing the car to move forward. And then there'll be a delay of 50 milliseconds, after which all of them are low. So then the car stops. So if I don't give this low thing after that, then the moment I type 1F, the car just moves forward the whole time. And I wouldn't want that, because in general, what you basically do is you're trying to implement this program for other uses. So you want it to continuously be able to give, you should be able to continuously give messages and the car should react dynamically. So you want it to have only a small amount of action for your message and then stop, so that you can go ahead and give the next message. And the smaller the delay, the slower the car would be, because you're actually giving that much, like it is moving forward only for 50 milliseconds here, but the more accurate it will be. So if you give a delay of a very high value, if you give 200 or 300, so or like 1000, so it's 1 second. So it will move forward for a whole second, which would actually be faster, because it's not waiting for commands again and again, but then the accuracy it's a trade-off basically. So you'll have to choose between whatever's the delay value that suits your project the best. And CG equal to B is the same thing. It's just the opposite way. LB is equal to high and RB is equal to high. So this allows the car to move back. Left, LB is equal to high and RF is equal to high. So this way, the left wheel moves backwards and the right wheel moves forwards. So if you can imagine it, the car would actually turn towards the left. And CG equal to R would be the corresponding thing for moving the car right. And CG equal to S will basically just stop the car in case you want to stop it in the middle of a particular command, if it's running. So this is the basic code for a car. I will put this in the Google Meet chat box, and to everyone who's viewing this from Teams can. 1 second, the whole thing isn't copied, is it? My bad. Yeah, so everyone who's using the YouTube stream can, I'll put it up in the WhatsApp chat later.
Excuse me, when we install the app which you told to, like this one, it is asking, would you like to install this device software, the Adafruits Industries? Is it okay? Should we install that or don't install?
I don't remember what that
You need to
option
install that Adafruits because it contains all the libraries you need.
Okay, thank you.
Okay, yeah, just probably install everything. If it's something that you can notice is probably some external software just for the sake of advertising or something, or like some kind of plan, that you can probably ignore.
The code is not getting copied fully because I guess there's a limit or something.
Right. I just noticed that as well.
Yeah.
So I'll just put everything towards the end in the WhatsApp groups. Why did we not use pin 12 in the Ldr circuit? Yeah, so basically, like Shreyas has answered, pin 12 is a digital pin. Actually, pin 11 is also a digital pin, but it does not have the tilde symbol. So basically, that means that it's not a digital pin that allows you to change the frequency at the rate and give it a certain duty cycle all of basically that function that you use analog, right? You can directly you can forget about the frequency and what the duty cycle should be. You can just give a value between 0 and 255, and you can just directly use the pin with the tilde symbol so that it allows you to give out a PWM signal. So the only reason is because it's a pin that cannot perform the PWM operation, that we don't use pin number 12.
Bro, Rishabh, when you do it physically, you're going to connect your laptop to the Arduino, right?
Right.
So this car one, how are we going to do it? Like,
okay, yeah. So basically, what you do is you connect your laptop to the Arduino. If you want to, like, if you're initially just uploading the code, you need to connect the car to the Arduino. But if you want to run it even after that, what you basically need to do is after uploading the code, all that the laptop does is most of the times just giving power to the Arduino board. So you can, if you see this, one second. In the Arduino Uno's pinout diagram, there is a V in and ground option here. So what you do is you can take an external battery and connect one of the wires to V in and the other to ground. So the positive to V in and the other to ground. So that way what happens is the Arduino is powered using that. So you can basically put all of that on the, like you can put the external battery also on the chassis itself, and the car would run by itself after that. And for giving input, basically because you're using the serial monitor when you're connected to the laptop, that is why we'll be looking into the Bluetooth module right now, so that you can give input using an app on your phone as well.
can you control it using Wi-Fi trans receiver or something? Like Bluetooth instance have to be near it, but somewhere far, can you use it?
There are Wi-Fi modules. I haven't really used any so far, but there are multiple ways in which you can actually communicate wirelessly. Bluetooth is one of them. That's the most widely used one. There's Wi-Fi also, and you can actually, if you have two Arduino boards, you can use a transmitter and a receiver. That's another module. You can actually buy a 433 hertz transmitter receiver, from which the range is actually even lesser than a Bluetooth module, so it would probably not be as functional unless you want to try to, like, let's say, make something like a gesture controlled wireless robot. So in that case, you want to be able to use the sensors of an Arduino itself to control an Arduino wirelessly. In that case, you can just use two Arduinos and a wireless transmitter receiver. But then, yeah, there are many options you can look into for if you want some kind of a better implementation. For
Are you going to teach us how to use the Bluetooth one, which you just mentioned?
Sorry?
Are you going to teach us are you going to teach us how to use the Bluetooth one, which you just mentioned?
Yeah, I'll be teaching that.
Thank you.
Yeah. So, oh yeah, we were looking into the code. Yeah, I'll put this code in the WhatsApp group after the session. So yeah, that's about making the code for a car and using a motor driver. That's pretty much it. And yeah. Now, this is the wiring, in case you guys wanted to see this as well. So you can see a 9-volt battery here connected to the motor driver. Oh yeah, this one thing, it's something that most people tend to forget when they're first trying to implement, and spend quite a lot of time trying to fix it. Even I did. You basically need to have a common ground between the Arduino and the motor driver. So you will need to connect the ground of the motor driver to the ground of the Arduino so that it works properly. So two motors here on the right, and the ground of the Arduino is connected to the ground of the motor driver as well. And here you're also giving the here the Arduino is the motor driver itself. So the 5-volt output that it's getting from the 9-volt here, and you could use actually you could use an external battery also. That might make things easier. And these are the 4 pins that you're using for INA, INA1, INA2, INB1, INB2. And here ENA and ENB have not been connected. So yeah, that's as far as the wiring is concerned. This is all that there is. Right. Yeah, we covered all this. Yeah, now looking into the Bluetooth module. Here you would only need 4 pins. The last 2 pins you can ignore. Those are pins, as far as I know, they are only used to kind of configure the Bluetooth module to probably, like, you can actually lock it, give your own password to it, and also give your own name to it. And also there are certain more settings that you can look into. But then these 4 pins are the only ones we'll need to be able to actually use the main features of it. RXD, TXD, ground, and VCC. So basically, this will also be connected to the Arduino itself. And along with all the other connections that you've made for the motor driver, if you connect this Bluetooth module, you will be able to send the commands. Basically, what this Bluetooth module does is the commands you want to send on the serial monitor, you will be able to send it directly using some other device, or wirelessly, basically. So wait, let me see if I've put the wiring here. 1 second. Yeah, okay. So basically, I'll show the connections later, but a VCC of the Bluetooth module, it's called HC05, is connected to a 5-volt power source. Ground is connected to ground. All of this is on the Arduino itself. And RXD of the Bluetooth module is connected to TXD. And TXD of the Bluetooth module is connected to the RXD. That is, if I show you the Arduino pin out again. Yeah. So you can see TX and RX over here on the bottom right. So TX of the Arduino will be connected to the RX of the Bluetooth module, and RX of the Arduino will be connected to the TX of the Bluetooth module. A transmitter receiver, basically. And one would make basically thing, but then you can just use it. So for any app that is a Bluetooth serial communication, can look up for it. BT Terminal isn't the app I use. I'll send the link for that also on the WhatsApp group after the class. So that way you can just connect it to the HC05. You'll have to switch on the Bluetooth of your phone and just connect to your HC05 using the app itself, and then you can send the commands on the using the app to the
Sir,
Arduino.
which is the app name? Like, what is the app name?
BT Terminal. I'll just write it here.
Thank you.
Yeah. When I use motor driver, I placed it completely on Arduino. Is it different? No, there are some shields that are available. So those pins just go into the Arduino directly, which makes things a little easier, sometimes a little cleaner when you're trying to present something or if you're trying to use something. But it actually doesn't make any difference. And yeah, one important point to remember when you're using the Bluetooth module is when you're trying to upload the code, you should not have the RXD and the TXD pins of the HC05 connected. First, you upload the code and then connect the RXD and TXD pins. It's because when you're uploading the code, this is also a Uart cable, the RXD and TXD pins. There is some kind of an error or confusion that comes up because of multiple communication lines being stored. Code successfully disconnect and connect that later. Yeah, and after this, you can actually implement a Bluetooth car. This is pretty much it. And I mean, there's one other topic I'll cover, but as far as the Bluetooth car is concerned, this is all that there is. So are there any other doubts?
Sir, how to use accelerometer with Arduino?
Accelerometer, there is one that I am aware of called the MPU 6050. It's a gyroscope and an accelerometer. So that is a thing you can try to look into. It would take me a little long to try and explain that. But if you just type MPU 6050 pinout and see how it works with the Arduino and the codes also. Wait, I think I have a code for that. Yeah, so I use this library called the token library. For some of the sensors and actuators, you will have to use some libraries, and then you will have to make an object of that library, like I have made over here. And then you basically, how an MPU 6050 works is it's a 6 degree of freedom IMU, inertial measurement unit. So an IMU basically allows you to sense the roll, pitch, yaw, and the X direction, Y direction, and Z direction. That would be the gyroscopic as well as the accelerometer values. So you can use this, and based on the gestures that you make, how much you tilt it, you can actually control a car also to move front, back, left, and right. And an MPU 6050 also has a thermometer built in it, so it can like sense the thermal, the temperature of its surroundings, and that
Can
also
you
is
please write that name in the chat box, like that module name?
yeah. Oh, okay. This is the sensor name, and I use a module called Token. You'll probably find the code on GitHub. You can actually install it if you just type Token module. But yeah, MPU 6050 is the name of the sensor.
Thank you. Thank you.
Yeah. So you can actually look into many other sensors and just see some of the widely used ones. People use servo motors a lot because you can actually, if you want to move something to a particular angle, that is what servo motors are used for, whether it be robotic arms or actually automatic doors, like I mentioned before. And ultrasonic sensors, which are used to sense if there's an obstacle present. And an even more complicated sensor, which I have not heard of being like used directly with only an Arduino, is a Lidar sensor, which you can use for implementations of SLAM, let's say, so you can make a map out of it. So, but that's not very related to Arduino, but you can search for sensors, and whenever you want to see how to use a sensor, all you need to do is probably just type sensor pinout, and a pinout is basically a diagram like this one, for example, or this one. So it helps you see all the pins, and then you can also search for the relevant codes and use them accordingly. Just, I think one of the best things to do is use the standard methods of how you print out the values to see what it is that the sensor is giving out, if it's an ultrasonic sensor or an LDR or even an MPU 6050, like I said. As and when you're turning it, you can see what the values it is that it's printing, and accordingly you can decide what the actuators are supposed to do. Okay, yeah. So that is everything regarding the blue car. This last thing that I'll be talking about. Yeah. So the last thing I'll be talking about is Spy Serial. This is something that you can use to send commands to your Arduino like serial monitor, but using Python. This is something you will be using if you're making image processing codes. So whatever it is that your image processing unit senses, based on that, you can actually tell the Arduino to perform certain things, whether it's a car, if you want to make it move right or left or front and back based on what it is that the camera is seeing, then you will be using PySerial to do that. So PySerial is all you need to do is you'll have to install Python and then install PySerial, and then you use you have to import serial, which is a module in Python, and this is a Python code. So it is not something you have to do in Arduino IDE. It is a Python code which you write separately, and then when you run this, it can communicate with the Arduino IDE, with the Arduino. So when you're using PySerial, you import serial, and then you can declare a variable with any name, and this is the function you need to use, serial.serial, and then it has 3 arguments. First is the port. So this you will have to check with your Arduino which port it uses. It'll either be COM 3, 4, 5, 6, or it can also have a different name that you will be able to see once you connect your Arduino to your laptop or to your computer. And you write your port name there, and you mention baud rate also. Like I mentioned, 9600 is what's generally used. And you write a timeout value. So the timeout value is basically if it is not receiving a signal, then what is the maximum time it will wait till. And then you basically, the main part of the PySerial implementation would be the variable name dot write I dot encode. So here I is taking the input from the user. So I equal to input is how you can take input and store it in this variable called I. So you're taking input from the user from this in this Python code, and then writing that input. I dot encode will allow you to write that input to the serial monitor. So rather than you giving F, B, R, or L, which I told you would be to control the car in the serial monitor, or if you're using the Bluetooth app BT terminal, rather than that, this is what would be used by PySerial. So you can actually use F, B, L, or R in the command line, or any other way that you're using this Python code to take input from. You can use that, and that will put it in the serial monitor and allow the car to run accordingly. So it always doesn't have to be input. So the main use of, like I told you, the main place where you could expect to be implementing this is when you're using, like when you're making image processing codes and combining that with the Arduino codes. So there you can probably say that based on what you're sensing, I's value would be either F, B, L, or R, and then the code would run accordingly. So if you can see in this code, I've just written while I is not equal to done, you just keep doing that. So if I type done, then the code stops. Other than that, it's just taking F, B, L, or R. That's about it, about PySerial as well. So yeah, if anyone has any doubts regarding everything that we covered today, you guys can ask now, even regarding PySerial. This is everything that we were supposed to complete in this workshop.
So can you repeat this PySerial part again?
Okay, so in Arduino, we code in the Arduino Ide, and you upload that code to the Arduino. And like I mentioned about the serial monitor, you use the serial monitor to take input and output from the Arduino and communicate with the Arduino using the serial monitor. That is, all of that is the normal way of doing it. And like when I mentioned about the Bluetooth module here, basically the only thing that the Bluetooth module was doing was allowing you to send the serial monitor commands wirelessly. So using another device. So when like the app that I told you about, you can just send the serial monitor commands from there. What PySerial does is using Python to send your serial monitor commands. So all of these are just like the Arduino codes are the same. The implementation is the same. It's just your serial monitor codes are like a serial monitor inputs are just being sent by another another place. Here you're using Python. So the reason this, like I mentioned, would be required is if you're using Python for some other implementation that you want to bring into the Arduino hardware. So like I said, image processing. When you guys are looking at image processing code, and based on, so let's say if there's a line follower robot that uses its camera to detect the line, and based on the color of the line, it's going to follow the line. So as soon as the line moves a little bit towards the left, then the Python code, which is actually going to be doing all the image processing part, can write using serial.write I.encode. You're basically going to give I is equal to L. So if the line is moving towards the left, then your car would move a little bit towards the left. So it's just integrating the image processing part with the hardware part. That is all that PySerial does.
Sir, do we need a separate library to implement this?
Yeah. You need a library called PySerial, and then you need to use this. You need to import serial. So you can install PySerial. I think if you just type pip install PySerial, it should work in Windows at least. Yeah, and you can also download it directly from the website. I'll send the link to this also in the WhatsApp group.
Okay. And then if we actually install that PySerial, then we can use Python code in Arduino.
Oh no, Arduino needs C++ code only. Python will only allow, like PySerial is only for serial, like as you can see in the name itself, it's only for the serial communication with Arduino.
Oh,
So it
okay.
will only be used for that part. Yeah.
Okay. Okay. Thank you.
Yeah.
So Arduino here is the processor, right? That's what.
It's a microcontroller. Yeah. It's the thing that is connecting the sensors and the actuators and allowing you to basically read the inputs and give out the outputs.
Okay, thanks.
Yeah. If you guys have no other doubts, I'll probably just tell you guys the task, and I'll also mention the task in the WhatsApp group. So if there's anyone who couldn't hear it or just had to leave the meeting earlier, you guys will know about it. So this task will be something that you'll have to submit after tomorrow's image processing code as well. So after tomorrow's image processing workshop. So that will also have a task, and this will be by 29th, basically 29th morning. That is what I have been told to tell you guys for the deadline. And based on these tasks, as it has been mentioned, the teams will be shortlisted. So the task you guys have is you guys just have to make the code. Obviously, hardware implementation would be a little hard as of now. But you guys just have to make the code for a line following and obstacle avoiding robot. So what we do over here is you will send like basically you will have to make a code which for a robot that has two LDRs connected to it, and two LDRs which are going to be sensing, which are going to be used to follow a line. So if I'll help you guys, 1 second.
Sir, IR sensor you use no sir to follow line, not LDR.
No, LDR, IR, both of them you can use actually. Yeah. So as you can see here, so LDR, the reason I said LDR is because what I want you guys to do is basically imagine here if you can see completely the task that I require you guys to do is basically use the map and use PWM to change the motors based on the brightness that the LDR senses. Okay, so it doesn't have to be replay the implementation here. So you can just assume that the black line, that it actually has the opacity increasing as the line is coming towards more of the center. So what happens is rather than completely switching off one of the motors and the other motor a little bit towards the, so you can suddenly towards the left to the right if it's starting to right from the path. What you wanted to do is to change the speed of the motors so that the Arduino can, so that the car can move smoothly. And the way this will be done is you basically have two LDRs. That's the reason I was pushing on LDR. So the LDR, what it will do is it will just take the input of the brightness of the surroundings and just assume that the brightness of the surroundings decreases in a continuous and uniform manner as and when the car is deviating from the path. And based on whichever LDR is sensing a lesser value, you will have to turn the corresponding motor to the like you'll have to decrease the speed of the opposite motor or corresponding motor that you guys will have to figure out on your own. So basically, you use the ENA and ENB pins. And
No, this is a doubt actually. The black line has the least brightness. So, and the surrounding, if it's white, then the thing is like if the surrounding is more brighter, then switch to another opposite side to black. But you said actually reverse that surrounding brightness is lower. How is it?
Oh, okay. Sorry. I must have said it by mistake. But yeah, obviously, the line in the middle is obviously it has the least brightness. So if it's deviating from the path, one of the LDRs will sense a lesser value. because of the darkness, because the opacity is increasing. So in general, both the LDRs will have a high value because the surroundings are brighter, because the floor is reflective and white.
Sir, the thing is like actually if you bend the LDR to the floor and there is no light coming from the front side, like it's completely bent down. So however light intensity is, it's bent down. So its resistance always keeps on same. Like there's no external light actually to trigger off the resistance and variate its resistance and give the output.
Actually, because I said that we'll assume that the floor is white and reflective, there is light that is entering the LDR because of the reflection of the surrounding sources of light. And as soon as it comes towards the center, deviating from the path, then that part is not reflecting any light. So the LDR gets a lesser value. And,
Okay.
Even if these hardware implementations don't seem very practical, because you're not working on a hardware, I only want you guys to submit the code. You guys can just be concerned about only about that part now, because this is only for the implementation of the code for the problem solving part of it. So you guys can just try and implement PWM and PySerial and everything together. I'll explain how you'll be using PySerial as well. And but yeah, as far as the hardware part is concerned, I think that even if you do connect it to the hardware, because of the reflection of the white surface of the floor, there will be a difference in the amount of light that the LDR senses. But yeah, it may not be very extremely accurate and efficient if you're using LDRs that way in actual hardware implementation. But like I said, you're only making the code right now, so it shouldn't cause any issues.
Sir, where should we submit the code?
Yeah, the submission, we'll update that to you on WhatsApp. I'll tell you from where. It will probably be a Google form, or it'll be a Google Drive link where you can actually make a folder with. You will have to make two codes basically. There'll be one code for your Arduino code and the other for your PySerial code. I'll tell you what the PySerial code will be. So the submission format, I'll let you guys know by tomorrow itself. But you guys can just be ready with the code till then. So. So basically, just repeating the problem statement that I've said so far, there will be two LDRs and they'll be connected to two motors using the motor driver. And based on the inputs of the LDRs, the motors have to move corresponding such that you're assuming that the darkest point is the line in the middle that the car is trying to follow. So you will have to make sure that both the LDRs are connected to the top left and the top right of the car. So both of them have to sense the high value of brightness and high level of brightness. And if one of them senses a low level, that means the car is deviating. So accordingly, you have to change the speed of the motors using the ENA and ENB pins. So ENA and ENB will be connected to PWM. And LDR values, you will have to sense using the analog pins, the way I just told you guys about how to use the LDR. And you will use the map function. You don't have to use the map function. You can actually use the indirect proportion, the way I told you how you can, without using the map function also, if you just make the mathematical expression for using an indirectly proportional relationship, you can do that also. So between 0 and 255 of the motor speed corresponding to what the LDR value gives, you can give that also. And for your implementation part, just assume that the LDR value is from 0 to 450, because you're not using hardware. You don't have any way to test what the LDR values are. So 0 to 450 is good enough. And using the map function or the indirect proportion, you change the speed of the motor. And for giving the, although this spicier part for this code is not required, you can directly just make the motors run forward the whole time. But so that you guys can get used to this, and this is also a part of the task, what you'll have to do is you will have to give the PySerial code. So using, you give the Python code such that the Python is basically PySerial is printing F to the car the whole time. So the car is continuously moving forward according to what the Python code is giving the serial monitor of the Arduino. And you're just changing the speeds of the motors in the Arduino code based on what the LDRs are sensing. So that way the left and the right turning part is automatically taken care of because of the differences in the speed of the motors. The only thing that the Python code is doing is sending forward the message forward to the the only thing that PySerial is doing, sending forward message to the Arduino. That's all. I'll send all of the things that I've just said. I'll write it all down and send it on the WhatsApp group once again, whatever the task is supposed to be. And but yeah, if you guys have any doubts regarding whatever I just told, you guys can ask.
Bro, I had a doubt regarding PySerial.
Yeah.
You just mentioned it downloaded from the website or something. After downloading it from the website or whatever you showed, like how are you going to integrate that with the Arduino code? Like you code it in Arduino, that's a different software. PySerial is a different software.
Yeah.
How are you going to merge it?
So basically, because you're giving the you're giving this serial port over here, no, in this function here. So when you run this Python code, it automatically also runs the Arduino code. So you've already uploaded the Arduino code to the Arduino board. And then when you're connected it to your laptop or your PC, when you give this port, Python knows that it is that port, like this PySerial knows that it is that port that it has to communicate with. So using that port, it sends the commands to the Arduino board. And the Arduino already has the code for the Arduino Ide uploaded in it.
Oh, okay, fine. Okay.
Yeah.
Thank you.
Yeah. Bro, your assignment is to... Oh, wait. An obstacle avoiding part. Once we go across the aisle. Oh, yeah. One more thing that I haven't mentioned. For the obstacle avoiding part, you guys will have to use a ultrasonic sensor. And you will have to... You can search for how to use an ultrasonic sensor. That is not something I've covered in the course, but that is one thing that I thought you guys can actually see how you can also just type sensor pinout and see how you can learn how to use a sensor only by using its pinout diagram by Googling it. That will actually be very helpful. So you just use an ultrasonic sensor and it is going to follow the line the way it was. Everything remains the same. The only difference is that there has to be one uppercase behind that, saying that if there is an obstacle that the ultrasonic sensor senses, then the speed of the motor should become 0. It should not be relevant with what the LDRs are sensing anymore. Because if there's an obstacle, then the program should just stop. So there doesn't have to be any more complicated thing by trying to navigate around the obstacle or anything. That is not something you guys have to worry about. So you guys can just, if there's an obstacle, the bot needs to stop. That's all. Irrespective of what the LDRs are doing. So this is using the ultrasonic sensor. And also, if this seems like too many things at once, you guys can even submit partial solutions. That's all right. The reason there has to be, the task has to be a little detailed is because we are trying to use this to shortlist teams. So we have to make sure that there is a way in which we can shortlist them. So even if you have partial solutions, you can submit it. It will be considered. Yeah.
Sir, actually, we can make a line follower robot with LDR sensors actually without using Arduino, using transistor triggers.
Okay, I haven't heard of that. If that works, then that's nice. But then for the task, we will obviously need to implement it using an Arduino itself. So.
Okay. Yeah, sure.
Yeah. No, those are not two different bots. I had to mention the obstacle avoiding part along with it. Sorry, I forgot to mention it in the same flow. But the obstacle avoider is just a case on top of the same bot. Yeah.
Can we implement the whole thing in one single Arduino file?
Yeah.
Or do we need to use a Python thing or?
Oh no, using PySerial is kind of necessary because, like I said, there are many people who have already had some kind of experience with Arduino, but when they transition to using image processing as well, which will obviously be required for this for the Robofest, you will need to understand how to use PySerial at one point of time or the other anyways. So using PySerial to send the forward command is required for this task so that you guys can actually implement it properly. Also, yeah, 29th morning being too early, that is something I am not in control of. I'll talk to the other organizers and I'll confirm what the main submission deadline is going to be. Should we use different libraries? No, the only library you'll be using is Serial, like I said, for Python. But
Sir, but ultrasonic sensor needs a different library to some of its commands, to use some of its direct commands.
okay, so whenever I have used an ultrasonic sensor, I haven't needed to use any library because you just need to connect the trick pin and echo pin and then see the difference in times. But if most probably, like, because like I said, I have heard of some cases where some of the hardware parts of some ultrasonic sensors, because they don't work directly, you need to install and use another library. But again, because this is only the software part of it, you don't need to use any library whatsoever, even for the ultrasonic code. You will be able to find codes which actually don't even require any library. So you will only need to use those pins, and the way you use a ultrasonic sensor by seeing the time difference and then calculating the distance based on that, that's all you need to do. And just set a particular distance level.
So actually, do we need a servo to just serve it around at least 180 degree for object detection?
No. You don't need to use any servo motor at all. It's only one ultrasonic sensor because the car will anyways be pointing towards the direction it's moving in the whole time. Because it's line follower. So it only needs to sense for obstacles at the immediate front of it. That's all.
Sir, but if it detects an object in its path, should it stop? Or what is it has to do?
It needs to stop. If it detects an obstacle in its path, it just, speed values you make it 0.
Okay, sir.
Yeah. No. You don't need to create any user-defined library or anything for obstacle and lane follower. You can just put all of that in one code as with the direct implementation, the way I have just showed you for using a car and the LDR and the ultrasonic. It can all just be in the file statements. There is no need for putting any library whatsoever. Yeah. Okay, if there aren't any more doubts, we can probably end the session here. I'll send the codes that we discussed about and the slides in the WhatsApp group, as well as I'll send the task once again. And I'll confirm about the deadline. If that is too tight, I'll try to see if I can change it. All right, guys. Thanks a lot.
Thank you.
Thank you.
Yeah. Good night.
Thank you. Good night.